What's up guys, this is Massey. Welcome to another video. In this video I want to talk about counting rules. So the first counting rule is if any one of m different events can occur on each of n trials, then the number of possible outcomes is equal to m to the power of n. Let's see an example. In this example, it says, suppose you toss a coin 6 times. What is the total number of different possible outcomes? So we're going to say we have basically 6 times. We toss a coin 6 times. So the first time we have 2 possible ways, head or tail, head or tail, head or tail. We do it 6 times. So it's going to be 1, 2, 3, 4, 5, 6. That's going to be 2 to the power of 6, which is 64. So the total number of outcomes is 64. Next example is, suppose you roll a die twice. How many different possible outcomes can occur? So if we assume that the roll is 6-sided, so we have 6 different ways times 6 different ways. So it's going to be 6 squared, which is 36 outcomes. So the answer is 36. Now let's look at rule number 2. Counting rule number 2 is saying that if there are m1 events on the first trial, m2 events on the second trial, and so on until you get m of n events on the nth trial, then the total number of outcomes is m1 times m2 all the way to mn. So basically you need to multiply all the number of events in each trial. Let's see an example. Here in this example it says, how many license plate numbers are available in Ontario if a license plate number consists of 4 letters followed by 3 numbers, which is 0 to 9. So we have 4 letters, so we have 26 times 26, 26 times 26, and then we have 10, 10, 10. So when you multiply that, 26 times 26 times 26 times 26 times 10 times 10 times 10, that's gonna give us the huge number 4, 5, 6, 9, 7, 6, 0, 0, 0. So that's going to be 456,976,000 different possible ways to have plate number in Ontario. Now next example, it's saying that a restaurant menu has a price fix complete dinner that consists of an appetizer, an entree, a beverage, and a dessert. You have a choice of 4 appetizers, 8 entrees, 3 beverages, and 5 desserts. Determine the total number of possible dinners. So the total number of possible dinners is going to be 4 appetizers times 8 entrees, 3 beverages, and 5 desserts. So you need to multiply all of them. 4 by 8 times 3 times 5. That's going to be 480 different number of possible dinners. So now rule number 3 is saying that the number of ways that all n items can be arranged is in order is n factorial equals to n times n minus 1 times n minus 2 all the way to 1. That shows n factorial. So for example, 4 factorial is 1 times 2 times 3 times 4. 7 factorial is 1 times 2 times 3 times 4 times 5 times 6 times 7. Now you have an example here. If a set of 5 books is to be placed on a shelf, in how many ways can the 5 books be arranged? So we're going to say that when we place the first one, the first position is occupied. So we have 4 more basically positions to be filled. So for the first one, we have 5 possible outcomes. For the second position, 4, 3, 2, and finally we have just one option. So you need to basically have 5 factorial, which is 5 times 4 times 3 times 2 times 1. That's going to be 120 different ways. Now let's see some examples. First one, it says a prospective car buyer can choose between a fixed and a variable interest rate and can also choose a payment period of 36 months, 48 months, 60 months. How many total outcomes are possible? So we can say fixed and variable, so 2 different ways, and based on the duration we have 3 different ways. So 2 times 3, we have 6 total outcomes, different possible deal. Now next example, it says a National Basketball League team will play 14 games during a regular season. Each game can result in one of 3 outcomes: a win, a loss, or a tie. How many total outcomes are possible? So it's going to be, we have win, loss, or tie in each game. So we have 3 times 3 times 3 all the way to 14 times. So total possible way is going to be 3 to the power of 14. So, and when we want to calculate it, 3 to the power of 14 will be 4782969. So it's going to be 4,782,969 different outcomes. Next example, how many different outcomes are possible for 4 rolls of a die? So if we assume that we have 6-sided die, so we have basically 6 times 6 times 6 times 6. So it's going to be 6 to the power of 4. So that's going to be 6 times 6 times 6 times 6. It's going to give us 1,296 different ways. Next question, it says how many different outcomes are possible for 8 tosses of a coin. So for each toss we have 2 different outcomes, head or tail. Head or tail for the first one. For the second one we have the same thing, head or tail, so 2 times again. For the third toss we have again head or tail, so we do 2 times 2 times 2 all the way to 8 tosses. So it's going to be 2 to the power of 8, or you can say 2 times 2 times 2 times 2 all the way to 8 times. So 2 to the power of 8 is going to be 256 times. Next example, a small ice cream shop has 8 flavors of ice cream and 4 kinds of toppings for its sundaes. How many different selections of 1 flavor ice cream and 1 kind of toppings are possible? So we're going to say we have 8 flavors and we have 4 kinds of toppings. So together is going to be 32 different ways in order to have different selections of flavor and toppings. Local telephone number is given by a sequence of 7 digits. How many different telephone numbers are there if their first digit cannot be 0? So we have 7 numbers. So the first one cannot be 0. So we have 9 different possible ways. Times 10, times 10, times 10, times 10. 1, 2, 3, 4, 5, 6, 7. So 9 times 10 times 10 times all the way to here. And we can calculate it. So it's going to be 9 times 10 to the power of 6. The answer is going to be 9,000,000, which is going to be 9 million different ways. Next one. The population of a town is 30,000 if each resident has 3 initials. Is it true that there must be at least 2 individuals with the same initials? So basically, the number of alphabets is going to be 26. So 26 times 26 times 26 this is for 3 initials. So that's going to be 26 to the power of 3. It's going to give me 17,576. So as you see here, 30,000 is greater than 17,576. So we're gonna say yes, it is true. Next example. A committee is to be chosen from among 8 mathematicians, 10 physicists, and 13 physicians. If the committee is to have 3 members of 3 different backgrounds, how many such committee can be chosen? So we're going to say 8 times 10 times 13. So 8 from mathematicians. We have 10 different ways to select physicists, and we have 13 different ways to select physicians. So it's going to be 8 times 10 times 13. That's going to give me 1048. Actually 1040. Yeah, 1040 different ways to have the committee with 3 different backgrounds. Next example. Here it says a committee is to be chosen from among 8 mathematicians, like previously the same example, but with a little bit of difference. We have 8 mathematicians, 10 physicists, and 13 physicians. If the committee is to have 2 members of different backgrounds, how many such committee can be chosen? So we're gonna say if we have 2 people from mathematician and physicist, it's gonna be 8 times 10. If one of them mathematician, the other one physician, we're gonna have 8 times 13. And if we have one from physicists and one from physicians, we're gonna have 10 times 13. So it's gonna be 80 plus 8 times 13 is gonna be 104. And 10 times 13 is gonna be 110, 30. So 80 plus 104 plus 130 is gonna be 314 different ways. The population of a town, that's basically like the other example we had. The population of a town is 30,000 if each resident has 1, 2, or 3 initials. Is it true there must be at least 2 individuals with the same initials? So number of initials is gonna be, it says 1, 2, or 3. The other example was just 3. 1 initial is gonna be 26, 2 initials is gonna be 26 times 26, and 3 initials is gonna be 26 times 26 times 26. So that's gonna be 26 plus 676. And then the other one is gonna be 17,576. So that's gonna be 18,278 individuals. So as you see here, still 30,000 is greater than 18,278. So we're gonna say yes, it is true. Now, next one. If there are 10 multiple choice questions on an exam, each having 4 possible answers, how many different sequence of answers there might be? So we're gonna have 4 different answers to the power of 10. So 4 to the power of 10 is gonna be 1048576, which is 1,048,576 different sequence of answers. So basically these are different examples you can have for counting rules. I hope you enjoyed this video. Please leave me a comment if you have any question. Please don't forget to subscribe to this channel. You can have access to many other videos regarding math, chemistry, and physics. Thank you for watching and have a great day.